DNA mutations and quantum tunneling. To have a brief explanation of quantum tunneling, we'll explain the sun nuclear fusion. Okay, so there is a nuclear fusion happening in the sun because hydrogen becomes helium, which is nuclear fusion because hydrogen is lighter than helium. The process of the nuclear fusion to occur needs a very high temperature, like 100 million Kelvin. But when they measure the temperature of the sunlight spectrum, but they could estimate the core temperature of the sun, which was approximately 700 Kelvin. As you can see, it looks impossible for the process or for the reaction to occur, for the nuclear fusion to occur. But it's like 4 times the temperature needed is like 4 times more than the temperature of the sun. Anyways, the particles penetrate the potential energy barrier higher than the kinetic energy, which seems impossible in the classical physics. So this gave us the introduction of the quantum tunneling, which is based on 2 things really: the superposition and the uncertainty principles. The superposition means that the particle or proton in our example can be in more than one position, and the uncertainty is about the momentum and its velocity. So to break this barrier, we don't really need this temperature to happen. Like, the process of the nuclear fusion does occur despite the low energy because of the uncertainty and the superposition. Okay, now in DNA, of course, in the DNA we have a bond, a hydrogen bond between every adenine and thymine and guanine and cytosine. Okay, but the DNA is of course dynamic because we have replications and unzipping, and so the unzipped DNA, we have to unzip it, we have to break the hydrogen bond, which is electrostatic bond. It's a weak bond. It works like, or functions like magnets. Anyways, okay, if we took the example of adenine and thymine, like if we zoomed in, the adenine and thymine, we have a hydrogen bond, we have hydrogen atom in one side. Okay, quantum tunneling does occur here because this hydrogen atom, due to the quantum tunneling, which is the uncertainty and superposition principles, the hydrogen atom may transfer to the other side. Okay, the hydrogen will go to the other side, which leads us to formation of the tautomer. Okay, this is called the tautomer shifting. In normal classical environment, the tautomeric shifting occurs via thermodynamically active process. Okay, but in the quantum tunneling, it can occur in the physiological temperature. This tautomeric shifting will lead us to the spontaneous mutations in the DNA. But why does this spontaneous mutation occur more in some individuals and less in others? We will know this in the next video.